A black hole is a region of space where gravity is so strong that nothing, not even light, can escape. They are interesting to study because they challenge our understanding of the laws of physics and have a variety of fascinating effects on their surroundings. The idea of a black hole was first proposed by John Michell in 1783, but it wasn't until the 20th century that they were taken seriously as a scientific concept. In the early 1900s, Albert Einstein's theory of general relativity predicted the existence of black holes. In the 1960s, scientists began discovering evidence of black holes in our galaxy and beyond, through observing their gravitational effects on nearby stars and gas. Stellar black holes are formed when a massive star dies and its core collapses, creating a singularity with infinite density and a gravitational pull so strong that nothing can escape. Intermediate black holes are more massive than stellar black holes but less massive than supermassive black holes, and their existence is still somewhat controversial. Supermassive black holes are found at the centers of most galaxies, including our own Milky Way, and are thought to have formed through the merging of multiple smaller black holes. Formation of black holes. Black holes are formed when massive stars run out of nuclear fuel and collapse under their own gravity, leading to a point of infinite density and zero volume, known as a singularity. The collapse of a star is initiated when its core can no longer produce enough pressure to balance the gravitational forces acting on it. This process can take place in two ways. The first is when a star with a mass of at least 3 times that of our Sun runs out of fuel and can no longer produce the energy needed to sustain its outer layers. As a result, the outer layers of the star collapse inward, creating an enormous gravitational force that crushes the core. The second way is when 2 stars merge and their combined mass is sufficient to trigger the gravitational collapse. Schwarzschild radius and event horizon. The Schwarzschild radius is the distance from the center of a black hole at which the escape velocity exceeds the speed of light. The radius defines the boundary of a black hole, known as the event horizon. Once an object crosses the event horizon, it is said to be in the black hole and cannot escape its gravitational pull. Conditions for black hole formation. For a black hole to form, there are 2 key conditions that must be met. The mass of the collapsing object must be sufficiently large, and the collapse must occur within a confined space. If the mass is not large enough, the gravitational force will not be strong enough to create the singularity. Conversely, if the collapse occurs in a space that is too large, the material will disperse, preventing the formation of a singularity. These conditions are why black holes are only formed from massive stars, which have enough mass to trigger the gravitational collapse necessary for singularity formation. Properties of black holes. The singularity. Black holes are defined by the presence of a singularity, a point of infinite density and zero volume at the center of the black hole. The laws of physics as we know them break down at the singularity, and scientists are still trying to understand what happens at this point. Effects of gravity near a black hole. The gravity near a black hole is so strong that it warps the fabric of space-time, causing time to slow down and space to curve. This effect, called gravitational lensing, allows scientists to observe the light from distant stars and galaxies that has been bent by a black hole's gravity. Hawking radiation and black hole evaporation. In 1974, physicist Stephen Hawking proposed that black holes should emit radiation due to quantum mechanical effects. This radiation is now known as Hawking radiation and is thought to cause black holes to slowly lose mass and eventually evaporate over time. The process of black hole evaporation is still not well understood, and many questions remain about its implications for the universe. Overall, black holes continue to be a fascinating and mysterious topic of study for astronomers and physicists alike, and their study has led to many groundbreaking discoveries in the field of astrophysics. Black holes in the universe. Black holes are some of the most fascinating and mysterious objects in the universe. They have captured the attention and imagination of astronomers and the public alike for decades. In this section, we will explore some of the examples of observed black holes, the role of black holes in galaxy formation and evolution, and how black holes can be detected and studied. Examples of observed black holes in our galaxy and beyond. There are 2 main types of black holes, stellar black holes and supermassive black holes. Stellar black holes are formed from the collapse of massive stars, while supermassive black holes are thought to be the result of the merger of smaller black holes and the accretion of gas and other matter. One example of a stellar black hole is Cygnus X1, which was discovered in 1964. It is located about 6,000 light-years away from Earth and is one of the strongest sources of X-rays in the sky. Another example is V616 Monocerotis, which is thought to be one of the closest known black holes to Earth, at a distance of about 3,000 light-years. Supermassive black holes are much larger and more massive than stellar black holes. One example is Sagittarius A, which is located at the center of our Milky Way galaxy. It has a mass of about 4 million times that of the Sun and is surrounded by a cluster of stars. Discussion of the role of black holes in galaxy formation and evolution. Black holes play an important role in the formation and evolution of galaxies. They are thought to form when massive stars collapse and can grow over time by accreting matter from their surroundings. As black holes grow, they release energy in the form of radiation and jets, which can influence the formation and evolution of galaxies. One example of this is the role of supermassive black holes in the formation of galaxy clusters. These clusters are made up of hundreds or thousands of galaxies that are held together by their mutual gravitational attraction. The energy released by supermassive black holes can heat the gas in the surrounding galaxy cluster, preventing it from cooling and forming new stars. Explanation of how black holes can be detected and studied. Black holes themselves are invisible, as they do not emit any radiation that can be detected by telescopes. However, their presence can be inferred by their effects on nearby matter. For example, if a black hole is in a binary system with a visible star, the gravitational pull of the black hole can cause the star to orbit it in a characteristic pattern. Other methods for detecting black holes include looking for the radiation emitted by matter as it falls into a black hole, and looking for the gravitational waves that are emitted when two black holes merge. In recent years, astronomers have made significant progress in understanding black holes and their properties. This includes the detection of gravitational waves from merging black holes, as well as the first ever image of a black hole's event horizon, which was captured in 2019 by the Event Horizon Telescope collaboration. Overall, black holes continue to be an exciting and important area of research in astrophysics, with much still to be discovered and understood. Theories and unanswered questions. Despite our significant progress in understanding black holes, there remain many unanswered questions and unresolved issues. One of the most significant challenges is reconciling general relativity with quantum mechanics, which are two fundamental physical theories that govern the behavior of the universe on vastly different scales. Current theories about black holes are based on general relativity, but they do not take into account the principles of quantum mechanics. This has led to a long-standing problem known as the information paradox, which suggests that information that falls into a black hole is lost forever. Another outstanding question is the nature of the singularity at the center of a black hole. According to general relativity, the singularity is a point of infinite density and zero size. However, this point is a breakdown of the theory, and it is unclear what happens to matter and energy that reach the singularity. Despite these limitations, scientists continue to study black holes using a variety of methods, including observing their effects on nearby matter, analyzing their gravitational waves, and simulating their behavior using advanced computer models. Through these efforts, we hope to continue unlocking the mysteries of black holes and gaining a better understanding of the universe we live in. In summary, black holes are fascinating and mysterious objects that have captivated the curiosity of scientists and the general public alike. The video covered the definition of black holes and why they are an interesting topic of study. The brief history of black hole research and the different types of black holes were also discussed, including stellar, intermediate, and supermassive black holes. The formation of black holes was explained, including how they form from the collapse of massive stars, the Schwarzschild radius, and event horizon. Properties of black holes, such as the singularity and its characteristics, the effects of gravity near a black hole, and Hawking radiation and black hole evaporation were also discussed. Examples of observed black holes in our galaxy and beyond, the role of black holes in galaxy formation and evolution, and how black holes can be detected and studied were explored. Theories and unanswered questions about black holes, such as the problem of reconciling general relativity with quantum mechanics, current theories about black holes and their limitations, and outstanding questions like the information paradox and the nature of the singularity were also discussed. It's important to continue research on black holes to deepen our understanding of these objects and the universe as a whole. The video encourages viewers to learn more about black holes and space exploration to satisfy their curiosity and expand their knowledge.